Imagine journeying to a star system far beyond our own, exploring worlds yet unseen by human eyes. The notion might seem like a plot straight out of a science fiction novel, but the fascination and allure of interstellar travel have gripped the human imagination for centuries. We live in an era where the boundaries of our knowledge are being pushed further than ever before. We've launched satellites that orbit our planet, sent astronauts to walk on the moon, and probes to the farthest reaches of our solar system. Yet the vast expanse of the universe remains largely unexplored, a tantalizing mystery that continues to captivate us. The cosmos is a siren, singing a song of exploration and discovery. It invites us to embark on a journey not just to the stars, but into the very heart of what it means to be human. Our curiosity, our thirst for knowledge, our unyielding spirit of exploration. These are the driving forces that compel us to reach for the stars. The dream of interstellar travel is not just about reaching new destinations. It's about the journey, about pushing our limits, about discovering what lies beyond the horizon. It's about answering the fundamental questions that have puzzled us for millennia. Are we alone in the universe? Is there another Earth-like planet out there? What secrets do the stars hold? The journey to the stars is fraught with challenges. The distances are mind-bogglingly vast. The environment's incredibly hostile. Yet we've proven time and time again that we are a species of explorers, innovators and dreamers. We've overcome countless obstacles in our quest to explore our own planet, and there's no reason to believe that space travel is any different. The possibilities of what we might discover are limitless. New worlds, new civilizations, new technologies. The universe is a treasure trove of knowledge waiting to be unlocked. And while the journey is daunting, the rewards are beyond measure. The vastness of space beckons, but will we ever be able to traverse its unfathomable distances? The answer lies not just in our technology, but in our determination, our ingenuity, and our unyielding spirit of exploration. Our journey to the stars begins much closer to home, with the first tentative steps taken by humanity into the cosmos. The thirst for exploration is not new to us. It's an inherent part of our DNA. But the exploration of space, that's a tale that begins in the mid-20th century. In the wake of the Second World War, two superpowers emerged, both eager to assert dominance on the global stage. The United States and the Soviet Union turned their eyes to the sky, igniting what would be known as the space race. It was a race that led to a series of milestones in the annals of space exploration. The first of these milestones was reached by the Soviet Union in 1957 with the launch of Sputnik, the first artificial satellite. This was followed by another Soviet achievement when Yuri Gagarin became the first human to orbit Earth in 1961. Not to be outdone, the United States set its sights on the moon. The Apollo missions, led by NASA, were a testament to human ingenuity and determination. In 1969, Apollo 11, carrying Neil Armstrong and Buzz Aldrin, made the historic journey, marking the first time humans set foot on the lunar surface. But our journey didn't stop there. Space probes like Voyager, Pioneer, and more recently, the Mars rovers, have extended our reach, exploring the farthest corners of our solar system and beyond. They've sent back data and images, expanding our understanding of the cosmos. These historical feats ignited our imaginations, fueling the dream of venturing beyond our solar system. Each milestone, from the first satellite to the latest Mars rover, has laid the foundation for future aspirations of interstellar travel. As we stand on the shoulders of these past achievements, we look forward to the next chapter in our cosmic journey, the exploration of worlds beyond our own. The stars may seem within reach when we gaze at them on a clear night, but the reality is far more daunting. The vastness of space presents a formidable barrier, with our closest star, Proxima Centauri, located over 4 light-years away. To put this into perspective, if we were to travel at the speed of the fastest spacecraft ever launched, it would still take us over 6,000 years to reach it. This is the astronomical equivalent of a stroll down the block. So the question arises, how do we overcome such staggering distances? Our current propulsion technologies, while impressive, are fundamentally limited. Conventional rocket engines, even those powered by nuclear energy, simply cannot provide the speed required for interstellar travel within a human lifespan. The solution, then, lies in developing new propulsion technologies that can push us to a significant fraction of the speed of light. Concepts like ion propulsion and solar sails are promising, with the former already in use on some spacecraft. Ion propulsion, which uses electric fields to accelerate ions and generate thrust, can theoretically achieve much higher speeds than chemical rockets. Solar sails, on the other hand, harness the momentum of photons from the sun to propel a spacecraft. Yet, even these technologies have their limitations. Ion engines require a large power source, which adds significant weight to the spacecraft. Solar sails, while energy efficient, are slow to accelerate and become less effective as the spacecraft moves away from the sun. More exotic ideas such as antimatter propulsion and warp drives are purely theoretical at this stage. Antimatter, the mirror image of normal matter, releases a tremendous amount of energy when it comes into contact with its counterpart, potentially providing the thrust needed for interstellar travel. Warp drives, a concept borrowed from science fiction, propose to bypass the speed of light limit by warping the fabric of space-time itself. Despite these challenges, relentless human ingenuity continues to seek ways of bridging this cosmic divide. Rocketing through the cosmos requires not just speed, but sustainable, efficient propulsion. As we delve into the realm of space exploration, we need to grasp the colossal challenges that interstellar travel presents. Our current propulsion technologies, while impressive, are not quite up to the task. So, how can we propel ourselves towards the stars? The answer lies in innovative propulsion technologies, some of which are already in existence while others are purely theoretical. Ion propulsion, for instance, is a technique already in use. It works by accelerating ions to create thrust, a method that's highly efficient though not particularly powerful. It's like a tortoise in space, slow to start, but once it's going, it can reach impressive speeds. Solar sails are another fascinating concept. These would harness the pressure of sunlight for propulsion, much like a boat uses the wind. It's a beautiful idea, turning the power of the sun into a cosmic tailwind. However, it's not without its challenges. Constructing a solar sail large and light enough to catch enough sunlight, yet sturdy enough to withstand the rigors of space travel, is a monumental task. Then, we have the realm of exotic propulsion, where we flirt with the boundaries of physics. One such concept is the warp drive, a hypothetical system that manipulates space-time to move a spacecraft. The idea, inspired by the world of science fiction, is to warp the fabric of space in front of and behind a spacecraft. This could, theoretically, allow us to traverse vast interstellar distances in a blink of an eye. However, it's important to note that this is purely theoretical and requires a form of energy that we are yet to discover. These are just a few of the ways we might one day propel ourselves to the stars. With every technological advancement, we inch closer to making the dream of interstellar travel a reality. It's a thrilling time to be alive, as we stand on the precipice of a new era of exploration, propelling towards the stars. The first ambassadors to the stars may not be humans, but our robotic emissaries. In the grand scheme of interstellar exploration, these mechanical explorers are our first line of contact, providing invaluable information without endangering human lives. In the quest to reach beyond our solar system, interstellar probes and missions are our best bet. The idea of interstellar probes isn't new. The Voyager spacecraft, launched in the 1970s, carry golden records filled with sounds and images of Earth, meant to represent our civilization to any extraterrestrial life that might encounter them. These spacecraft, now in interstellar space, were our first unintentional interstellar probes. But intentional interstellar missions are a different story. They would need to deal with distances so immense that it would take tens of thousands of years for our current fastest spacecraft to reach even the nearest stars. This is where the concept of generational probes comes in. Spacecraft that operate over centuries, with each generation of robots building the next. Sounds like science fiction, doesn't it? But it's a concept that scientists are seriously considering. And then there are the breakthrough Starshot missions. The idea here is to send a fleet of tiny, lightweight spacecraft propelled by powerful laser beams from Earth to the nearest star system, Alpha Centauri. These nanocrafts, traveling at a fifth of the speed of light, could reach Alpha Centauri in just over 20 years. These missions, however challenging, offer us a multitude of benefits. Apart from getting a close-up view of other star systems, they can search for exoplanets, look for signs of extraterrestrial life, and test the laws of physics in different parts of the universe. They would also lay the groundwork for future manned missions, helping us understand the challenges and risks involved in interstellar travel. These robotic pioneers may pave the way for humanity's journey to the stars. They are not just machines, but embodiments of our curiosity and our desire to reach beyond the confines of our solar system. As we stand on the threshold of the interstellar age, these probes are our first step into the vast cosmic ocean. While we engineer our way through physical constraints, theoretical physics offers tantalizing possibilities. So, let's delve into the realm of theoretical concepts that could potentially help us overcome the limitations of current physics and propel us beyond our solar system. One concept that has captured the imagination of scientists and science fiction fans alike is the Alcubierre warp drive. Proposed by Mexican physicist Miguel Alcubierre, this speculative idea involves creating a warp bubble that would expand space-time behind a spacecraft and contract it in front, allowing the ship to traverse vast distances in a blink. However, this concept remains far from reality, requiring exotic matter and energy forms not yet discovered or understood. Another exciting proposition is the use of wormholes. These theoretical passages through space-time could potentially offer shortcuts to distant parts of the universe. But, like warp drives, they remain firmly within the realm of the theoretical, with the current understanding of physics unable to accommodate their existence without exotic, undiscovered forms of matter and energy. As we ponder these theoretical concepts, the importance of exploring exoplanets comes into play. These celestial bodies, orbiting stars outside our solar system, may hold the key to potential destinations for interstellar travel. The discovery and study of exoplanets have taken center stage in the quest for life beyond Earth. Kepler, a space telescope launched by NASA, has been instrumental in detecting thousands of these distant worlds, a few of which reside in the so-called habitable zone, where conditions could potentially support life as we know it. The study of these exoplanets not only fuels our curiosity about the universe, but also provides invaluable insights into the possibilities of interstellar travel. By studying their atmospheres, climates, and geological features, we can better understand the challenges and opportunities that await us in the cosmic ocean. As we push the boundaries of our understanding, we may yet find a way to voyage to the stars. As we continue to explore and innovate, perhaps one day, we'll be able to turn these theoretical concepts into reality and set sail for the exoplanets that beckon us from across the cosmos. As we stand on the cusp of this grand endeavor, we must consider both the when and the should. Interstellar travel, the dream of generations, is no longer a question of if, but of when. The timeline, however, remains speculative at best. Despite advancements in propulsion technologies, the sheer distances between stars mean that journey times, even at the speed of light, would span years or even decades. Realistically, without a significant leap in our understanding and manipulation of physics, we could be a few centuries away from achieving this dream. But let's say we do make that leap. We develop warp drives or discover wormholes. Suddenly the stars are within our reach. But should we reach out? This is where we grapple with the ethical considerations of interstellar travel. The discovery of extraterrestrial life, even microbial, would be groundbreaking. But what if our arrival disrupts their natural evolution? What if our pathogens wipe them out, or vice versa? We've seen the devastating effects of such scenarios in our own history, when civilizations with different levels of technological advancement have come into contact. And then there's the responsibility of exploration. As we venture out into the cosmos, do we have a duty to preserve these new worlds, to leave them untouched for future generations to study and appreciate? Or do we have the right to exploit them for resources to ensure our own survival and prosperity? These questions may seem premature given the current state of our technology, but they are crucial to consider as we continue to push the boundaries of what's possible. Addressing these ethical dilemmas now can guide our actions in the future, shaping a spacefaring civilization that is not only technologically advanced, but also thoughtful and responsible. Interstellar travel presents not just technical challenges, but ethical ones, a testament to the profound impact such a feat would have on our species and potentially others. The prospect of interstellar travel is more than just science fiction. It's a future that, while distant, may well be within our grasp. As we've seen, the journey to reach beyond our solar system is riddled with challenges. The vast distances, the limitations of current propulsion technologies, the need for advanced materials and life support systems, all paint a picture of a monumental task. Yet the same could have been said about landing on the moon just over half a century ago. With every passing day, we push the boundaries of what's possible, inching closer to the stars. Theoretical concepts like the Alcubierre warp drive, advancements in ion propulsion, and the potential role of artificial intelligence may one day open up the cosmos for us to explore. As we gaze up at the stars, we can dream of the day when we might finally set course for a distant world, embarking on the grandest adventure of all, a journey to the stars.